Check it. Customized pins, wise men, I'm tied in. The environment I'm in, it's like a lion's den. Tied right into the thigh length. I run with the climate.
So, MN signifies midpoint approximation. Trying to cross the X here. Okay, approximation. Alright, so this is going to be, we're going to have the same thing. I'll draw a little diagram again. So X and Y, and we have some curvy thing looking like that. And again, the same integral that we're trying to evaluate, or approximate, right? So here we're going to have A to B, and then N, again, is the number of, like, they call them sub-integrals, or sub-intervals, sorry, intervals. When you do this so long, interval it just blends with integral, so I'm sorry. N equals the number of sub-intervals. So we're evaluating from A to B, right? So on this, we're trying to find the area under the curve. And let's say in this case it's going to be 3, just for explanation's sake. So we're going to have 3 sub-intervals here. So A equals x naught again, and B this time is xn, which now is x3. So this is x1 and x2. Okay, so these are they're even intervals. And we also have, so this is midpoint approximation. So basically we're going to be evaluating, or what we're going to be interested in is the value of the function in the middle of these sub-intervals. So let's take our first sub-interval. This is from x0 to, to x1, right? So this is our first little interval, okay? So the midpoint of this would be x1 minus x0 over 2, because that's like the average, right? That'll be our point right here, our x value. So then what we're going to be doing with midpoint is taking that middle point and drawing a line straight. I tried to draw straight. Okay, I'll try down instead. Okay, so we're taking the midpoint and evaluating the function there. Okay, so then we're going to do the same thing here. So from x1 to x2, here's the midpoint, and then we're going to go straight up and down. Here's our point there, and then same thing for the last one. Here's our middle, and then we go straight up right here. Okay, and what I like to do, I just draw, well, I draw the points in where it touches the graph, the points of interest, and then at the rest of the intervals, I draw a line straight up, all the way up, passing the graph, okay? So we're going to have a lot of lines here. I know it looks confusing, but it'll make sense. So with midpoint, what we do now is we just chop each interval at the point of interest. So from x0 to x1, here's our point of interest, and we're going to chop straight across horizontally. Okay? So now from x1 to x2, we find the point of interest, and we go straight across. And then same thing with the last one. We just go straight across. So here are rectangles that we're going to be using to approximate the area. Okay, that looks better. And then, I mean, I just draw the vertical lines because it helps me. But, yeah. So that is a useful way to go. Okay, so our value of mn is actually going to be, so here's our formula. We have a delta x. So this would be like the width of our rectangles. So these are all uniform, right? Because they're all going to be delta x. And then we have f of, and then, okay, so I'll just write it down. So C1 plus F C2 plus ... up until FCN. And this C, that just means your midpoint. So this is like your C1, okay? Yeah, so this is the midpoint of your interval, okay? So here's our C1 right here, and then this is C2, and this is C3. Sorry, it's kind of crowded in here. It's kind of small. Okay.
Fuck out of here. Motherfucker.